All right, good evening or afternoon or morning whenever you're watching this video. So I just thought I would do the review for quiz 19 and post a video on haiku for you. So for questions numbers 1, 2, 3, and 4, it says for the directions, use a given point on a terminal side of the angle theta in standard position to evaluate the 6 trigonometric functions of angle theta. So for these problems, what we can do is step 1 is quickly sketch a graph. So the point 6, -2 is going to be in quadrant 4. So here's the point on the terminal side. Remember, the initial side goes along the positive x-axis, and there's the terminal side. Don't have to be exact, but just gives us a good point. And remember from class, hopefully, you can make a right triangle out of this. Call this 6 and call this -2. Here's your angle theta. And you can use that to help you set up your triangle. All right, what you need to do is in step 1, find r. So r is going to equal the square root of x squared plus y squared. So r equals the square root of 6 squared plus -2 squared. So that's where we get r equals the square root of 40. Yep. So we get r equals 2 square roots of 10. So then we can write our 6 trigonometric functions. So we have the sine of theta, cosine of theta, tangent of theta. We have the cosecant of theta. We have the secant of theta. And we have the cotangent of theta. All right, so from class, the notes, we define sine of theta as y over r. So the y coordinate was -2 over r, which is 2 square roots of 10. When you simplify that, the 2's cancel and you rationalize, so you have negative square root of 10 over 10. Cosine of theta was x over r, so you have 6 over 2 root 10. When you simplify, you have 3 root 10 over 10. Tangent is y over x, so -2 over 6, which equals -1/3. And then we are going to flip these. So cosecant is the reciprocal of the sine, so that's where we get negative the square root of 10. Secant is the reciprocal of the cosine of theta, so that's where we get the square root of 10 over 3. And the cotangent will be just simply -3. All right, so basically that's what we're going to do in each process. Now you should draw the triangle. If you don't want to memorize the y over r, x over r, y over x formulas for sine, cosine, tangent, remember you can always draw the triangle. R was 2 root 10, and you can always use SOHCAHTOA, whatever way you want to do it. So for the rest of the problems, I'm just going to skip the picture, go straight to finding r. So r equals the square root of x squared, so -7 squared, plus y squared. So we have r equals the square root of 49 plus 25. So we have r equals the square root, that's going to be 6, that's going to be 74. And I don't think that simplifies. So we have the sine of theta, we have the cosine of theta, tangent of theta, cosecant of theta, secant of theta, and cotangent of theta. All right, sine is going to be y over r, so we have 5 over the square root of 74. Which simplifies to 5 root 74 over 74. Cosine is x over r, so -7 over the square root of 74, which equals -7 square roots of 74 over 74. And then tangent is y over x. Then we have the reciprocals, so this is going to be the square root of 74 over 5. Then we have negative the square root of 74 over 7. And then we have 5 over -7. For number 3, we have r equals the square root of 4 squared plus 8 squared. So r equals the square root of 16 plus 64. So r equals, that's going to be 80, square root of 80. Which I believe is 16 times 5, so r equals 4 root 5. Sine of theta, cosine of theta, tangent of theta, cosecant of theta, secant of theta, and cotangent of theta. All right, so sine is y over r, 8 over 4 root 5. So we have 2 root 5 over 5. Cosine is x over r, so we have 4 over 4 root 5, which will leave us as square root of 5 over 5. Tangent is y over x, 8 over 4, which equals 2. And then we have our reciprocals. So this one will be square root of 5 over 2. This one will be the square root of 5. And then this one will be 1/2. Okay, number 4, we have r equals the square root of negative 12 squared plus negative 3 squared. So we have r equals the square root of 144 plus 9. So r equals the square root of 153. I don't think that simplifies off the top of my head. It could, but I don't know. I don't think so. Yeah, right. Here's my 6 trigonometric functions. So sine is y over r, negative 3 over the square root of 153. So that equals negative 3 square roots of 153 over 153. Cosine is negative 12 over the square root of 153. So that equals negative 12 square roots of 153 over 153. Tangent is y over x, so negative 3 over negative 12, which equals 1/4. Our reciprocals, square root of 153 over negative 3, square root of 153 over negative 12, and then 4. All right. Okay, so evaluate that using the calculator. So step 1, cosine of 150 degrees. Cosine 150. 150 is in quadrant 2. All right, here is 150. My coterminal angle is 30 degrees. And remember, you can find that by doing 180 degrees minus 150 in quadrant 2. Set up my side ratios. Side opposite to 30 is 1, opposite to 60 is the square root of 3, and side opposite to 90 is 2. Label the square root of 3 negative. All right, so we want cosine. So cosine of 150 degrees is equal to adjacent over hypotenuse. The adjacent side is negative the square root of 3 over 2, and I am done. Okay. Tangent of 8 pi over 3. So you could convert 8 pi over 3 if you don't like it. Remember, in pre-calculus, you're going to have to like it. So 3 goes into 180, I believe 60 times. 60 times 8 is 480, and then let's subtract the 360. So we're going to get 120 degrees. So this is really equivalent to 120 degrees. That's going to be in quadrant 2. So here's 120 degrees. The coterminal angle will be 60 degrees. And again, you can find that same way. Side opposite to 30 is 1, opposite to 60 is the square root of 3, and then 2, this will be negative. All right, so tangent of 120 degrees is equal to opposite over adjacent, which equals negative square root of 3. All right, sine. So 840, negative. So let's go to negative 840. Let's add a 360, coterminal angle. Let's add another 360. Let's add another 360. So this is equivalent to the sine of 240 degrees. All right, 240 degrees is in quadrant 3. Okay, in quadrant 3, I'll do this one out. It's theta, 240 degrees minus 180 degrees. And that is going to give us our reference angle of 60 degrees. So here is how I got 60 degrees, and here's 30. Opposite to 30 is 1, opposite to 60 is the square root of 3, and then 2, negative and negative. So the sine of 240 degrees is equal to opposite, negative square root of 3 over hypotenuse of 2. There you go. All right, so again, negative 15 pi over 4. Let's go ahead and convert that. 180 degrees over pi. The pi's cancel. So 180 divided by 4, let's do that one first, times 15, and I get negative 675. I don't like that, so let's add a 360. Let's get it to be positive. Oops. So 675 negative, because that's what I got there, plus 360, plus another 360, and that's going to give me 45 degrees. So this is equivalent to the secant of 45 degrees. If I draw that here, here's that angle, 45 degrees, 45 degrees, 1, 1, square root of 2. Secant is 1 over the cosine. So we have hypotenuse over adjacent. Hypotenuse is the square root of 2 over 1, square root of 2. All right. So for number 9, okay, so remember, the inverse cosine is defined in quadrants 1 or quadrants 2. This is negative, so I want to draw the angle in quadrant 2. The trick I gave in class was, let's go ahead and think about that, what it was before I rationalized. So let's draw this triangle in quadrant 2. Here's my theta. Cosine is adjacent over hypotenuse. So the adjacent side is -1. Hypotenuse is the square root of 2. This must be 1. So what special triangle must that be? Well, that must be a 45-degree angle. But what is it in this quadrant? All right, so it's going to be 180 degrees minus 45 degrees, and that's going to give me 135 degrees. All right, sine, -1. Okay, so sine is the same thing as y over r. So that's my y coordinate, and there's my r. This one's a weird one. So y here is -1, and r is 1. So this actually is on a unit circle, and that's at 270 degrees. Okay, or remember, sine is only defined between 1 and 4 quadrants, right? So it's got to be quadrant 4. So really, we're looking for the -90 degrees. Oh, by the way, we want to also give the radians. So let's make sure we give the radians for these both answers. All right, tangent defined in quadrants 1 and 4. This is positive, so we want quadrant 1. Square root of 3 over 3, I'm going to go backwards and make that 1 over the square root of 3. So triangle in quadrant 1. Tangent is opposite over adjacent, 1 square root of 3. Oh my goodness, that's 2. Side opposite of 1 is a 30 degree. That must be 60 degrees. So my answer is 30 degrees, or pi over 6. All right, cosine, again, defined in quadrants 1 or 2. This is positive, so it's got to be quadrant 1. Adjacent over hypotenuse. Let's draw it in quadrant 1. All right, adjacent side is 1, hypotenuse is 2. That must be the square root of 3. Side opposite the square root of 3 is 60 degrees. That's 30 degrees. So my answer is 60 degrees, or pi over 3. There we go. All right. So number 13, theta is going to equal the inverse sine of 0.3. So theta is going to equal inverse sine of 0.3. And I get 17.5. Now, I want this to be between 90 degrees and 180 degrees. So what I'm going to do is do 180 degrees minus 17.5 degrees. And I am going to get my answer of 162.5. All right, 14. So theta is going to equal the inverse tangent of 6. So theta equals the second inverse tangent of 6. And I get 80.5. All right, so in quadrant 3, I want to do 180 degrees plus 80.5 degrees. And I get 260.5. All right, 15. Theta equals the inverse cosine of -0.72. So theta equals inverse cosine of -0.72. I get 136.1. In quadrant, this one, okay, so this one's going to be a little bit weird. So I want this to be in quadrant 2. Guess what? This is in quadrant 2. I'm done. Angle's already there, don't do anything. All right, so theta equals the inverse sine of negative 0.55. Inverse sine of negative 0.55. And I get theta equals negative 33. So theta equals negative 33.4 degrees. In quadrant 4, I do 360 minus 33.4 degrees. And I get my angle of 326.6 degrees. All right, and then number 17. So a stuntman uses a 30-foot rope to swing 136 degrees between two platforms of equal height, grazing the ground in the middle of the swing. Okay, so we have a platform here. We have another platform here. All right, so we have a stuntman up here, and he has a rope. He's going to graze the ground, touch it, and come back up. So something like this, not quite realistic. And he's going to swing 136 degrees. 30-foot rope. So I'm guessing this is 30 feet. Shoot, it comes back up here. Grazing the ground in the middle of the swing, and the rope stays taut throughout the swing. How far above the ground was this? So we want to know this height at the beginning and at the end of the swing, and then how far apart are the two platforms. Okay, so then 136 degrees between two platforms of equal height. I'm guessing a stuntman uses 30-foot rope to swing 136 degrees. I think this angle here is 136 degrees. I'm thinking this angle here is 136 degrees. So what I want to do is do 180 minus 136. And I want to divide that by 2. So I want to get 22 degrees down here on either side. So I want to set up this trig function. We call that A. Okay. Sine of 22 degrees equals the opposite over the hypotenuse. So H equals 30 times the sine of 22 degrees. Let's see if that could be the right answer. 30 times the sine of 22 degrees. And I'm getting the height H equals 11.2. Not quite. Okay. What if I do 30 times the sine of 44? That's probably too much. Well, I'm thinking this might be an answer here. The way I drew the picture, let's do it that way. Okay, so that's your height. And then let's look at A. So A is going to be the cosine of 22 degrees equals the adjacent over the hypotenuse. You know what? I wonder real quick, what if that's supposed to be 15 times the sine of 22? Nope, that doesn't work. Okay, anyways, so cosine of 22 degrees, so A is going to equal 30 times the cosine of 22 degrees. So 30 times the cosine of 22 degrees. And I'm getting A is equal to 27.8. And then I need to multiply that by 2 because that's only part of it. And I'm getting 50. A equals 55.6 feet. Is that what I got? So I'm thinking this probably should be 11.2 on your answer sheet. And that's correct. The way I drew the picture, that's what I'm looking at. All right. So there you go for your quiz.